It takes a little bit for the screen share to start. Oh, wow, why is it freaking out like that? Okay, I don't know if you saw the flashing. I saw flashing and it was like, oh, it's gonna give me a seizure. Okay, so what I'm covering today is 1.8, which is solving other inequalities. And so these are the polynomial inequalities and the rational inequalities. The polynomial inequalities, we most often see quadratic inequalities, and those show up in business quite a lot. But rational inequalities do exist as well in the real world. It really depends on the situation and how it gets modeled. And then also there are non-linear inequalities to model and solve real life problems. So that's where you can actually see some examples of where you would need to know these kind of things. So I'm going to go straight into it with the steps and then examples. So first off with the polynomial inequalities. And this is the one I know that I have a video in the classroom in the weekly content. But I know those videos are low budget videos made on my own. You know, you can't really see things the way on the whiteboard as well as you can see now that I have better technology. So the way these work is that you have to have one side be 0. Usually we always make the right side 0. If you don't have 0 on one side, you can't use this method. So you have to do whatever you can to get everything on one side. Once you've done that, then you factor. If it's something you can't factor, then you need to use the quadratic formula. So you factor, you set each factor to 0, solve for the variable. So you're basically looking for where the inequality is equal, or where your quadratic, cubic, whatever you have, your polynomial is equal to 0. Because at those points, if you're thinking of, let's say a 2D graph, we're looking for where the x value, or where the y value is 0, if you're thinking about something graphed. And so if you have a y value of 0, if I try to, I'm doing pictures in my hands, guys, that you can't see that while I'm sharing my screen. So let's say we've got x and y. So if you have something that has a y value of 0, and you know what x value that's at, then it's going to change directions. It's either going to be negative to the left and positive to the right, or it could potentially be positive and then negative as far as the y value goes. So it changes sign, and whatever your shape is, your polynomial will change sign because it's 0, and then it's either going to be a negative number or a positive number after when it hits a 0. So we're looking for where it hits 0, so that way we can look to see where it's positive and negative. And we care about that because the inequality is compared to 0, whether something is greater than 0 or less than 0. So we're looking to basically, when we're looking at these inequalities, we look at how they're compared at 0 to look at whether it's positive or negative. So in order to figure that out, we have to figure out first where it's equal to 0 so we can see where it's going to change. And so you factor and set each thing equal to 0, or you can use the quadratic formula if it's something that doesn't factor. But for these problems, they usually make something that's going to factor. But you basically need to know where it's equal to 0 so you can see where it might potentially change signs. And then you do what I call a sign chart. So the textbook makes a similar chart, but it does versus true and false, and it puts it in the original polynomial. I put it in the factored form because it's easier, and then you're just multiplying and dividing things and figuring out the sign of the result. So I do it slightly differently. The way that I do it with the sign chart is similar to what you would do if you were going on to calculus. So that's why I do it that way versus the true false that the textbook does. But you can do it the way the textbook does. I just think it's a lot easier to plug in numbers the way I do it. So the sign chart, basically you have a number line of just x values, and you mark at each point that it's equal to 0. And then if it's a less than or greater than symbol with the 0, you're going to put dashed vertical lines at your zeros, and the dashed means that point's not included. If it's a less than or equal to or greater than or equal to, you're going to draw a solid line at the zeros, And that just indicates that those are allowed to also be part of the solution. Then you create rows for each factor, and then you basically multiply the signs, and that goes underneath your number line. And so you plug in numbers, determine if it's positive or negative, write that down, and then multiply, and then you look at the chart for your solution. So this will make a lot more sense when you see how it's worked out. And what I would recommend doing, if you're reviewing this video again after the fact, is to print out the steps here, and then have these steps handy while you watch the video so you can see how we're working through each step. But I can't show 2 slides at once, and there's not enough room for me to put these all in a slide and show work. So you're just going to have to rely on watching me for now, and then you can print it out later to review it. So here's my first example, and I've already sort of set up the chart here on the right so you can see how this is going to work. We have something that's a quadratic, it's x squared. So that means I'm going to have 2 factors. So that's how I know that I have factor 1 and factor 2. So the degree of the polynomial, and we talk about degree in P.3, the degree, which is the highest exponent, that tells you how many factors you're going to be looking at, and essentially how many 0 points we're going to be looking at. And so that's why I have 2 little vertical lines there. Those are where my zeros are going to be. So you want to have one side have 0. So I've already got the right side, which is 0. So I can go straight to factor. So I'm going to do this all on the left so that I have plenty of room. And we've got x squared minus 2x minus 8. And this factors to x minus 4x plus 2. So this is where you really want to be good at factoring so that you can do these quickly. So negative 4 and 2 multiplied to negative 8. Negative 4 plus 2 gives you negative 2. So you factor. And then you set each factor equal to 0, just like when we were solving a 1-4. And then you solve for x. So we get x is equal to 4, x is equal to negative 2. And now those are the points that I'm going to have as my transitions, and I'm going to put them in order on my number lines. So 2 is smaller than 4, so that's going to be the first number. And I've put those where my little lines are. Now, because our symbol is greater than or equal to, then I'm going to have solid lines. So I'm going to do this with a different color. And I'm going to draw solid lines just to separate this number line up so that you've got 3 separate sections there. So I've separated it out into 3 sections, a left, a middle, and a right. And it's solid because it's a greater than or equal to sign. So I can even just indicate that. So it's a solid line. Okay, now I'm going to look at the factors. So it doesn't matter which one is in what order, but I'm going to just write the first factor, which is x minus 4, and then the next one, which is x plus 2. And I'm just going to put them right next to where I have labeled the factors, and then underneath my number line I have multiplication. So here's how this works, and I'm going to change colors yet again. So you're plugging in numbers in each section of the number line. So on the left section, I want to plug in a number that's smaller than negative 2, to the left of negative 2. And you want to try to plug in numbers that are easy as possible, so like negative 3. So you're plugging these in to the factors. So like if I have, say, x is equal to negative 3, then when I plug that into x minus 4, I have negative 3 minus 4, which is negative 7. And that's a negative. I'm going to just put a negative sign right there. And then I also plug it into x plus 2. So negative 3 plus 2 is negative 1. That is also negative. So I'm going to put a negative sign there. Now if we look at our original, our factored form had these 2 multiplied together. So we multiply those 2 signs together. A negative times a negative is a positive, so the result of the multiplication is positive. So I'm going to write positive underneath. Then I do the same thing with a number between -2 and 4. I usually don't even write down these steps because I can do these mentally, basically. You pick numbers that are easy enough to plug in. All you're doing is adding and subtracting to that number, so it's usually really easy to do in your head. So if I plug in x equals 0, and then in x minus 4, 0 minus 4 gives me -4. So I'm going to have a negative. And then in x plus 2, 0 plus 2 gives me a positive 2. So I'm going to write plus. And then I multiply those. Negative times a positive is a negative. So I'm going to write a negative underneath. Then I do the same thing for a number larger than 4. So let's say we choose 5. So 5 minus 4 is 1. So that's going to be a positive. And then 5 plus 7, that's also positive. And then a positive times a positive is a positive. So now I've filled in my sign chart. So I am plugging them into the factors where all I have to do is add or subtract. The textbook wants you to plug these numbers to x squared minus 2x minus 8. It's a lot harder to do in your head. And you need a calculator for that. The way I do it, you can do it in your head essentially. So now that you've made that chart, how do you know what your solution is? Well, we are looking for things that are greater than or equal to 0. So that's positive. So we are looking for the areas of our chart where we are positive when you multiply. So I'm looking for basically the left and the right and not the middle. So those are how you determine where your solution is. So we're looking for if it's greater than or equal to 0, then we're looking for the positive parts. And so then you read it off with your interval notation, basically the parts that are positive. So if I start from the left, I have negative infinity as my left endpoint. If I'm reading it from left to right, and that always has a parenthesis, then I stop highlighting at -2, and because of the greater than or equal to, that's a bracket. So the rules for this match the rules for the linear inequalities. Then because I have a gap, I have to combine that with the right side, which starts at 4, and it's also including 4 because the greater than or equal to. And then that goes to positive infinity, which has a parenthesis. And so that's how you know what your answer is. So you have to basically look at whether it's going to be positive or negative in each section. And then once you figure out the overall, so I do it one by one and then multiply, that will determine where in your number line you have the solution. So are there any questions so far? Okay. Here's another example. So this one, oh, I see a message. Okay, so will it stay the same if there are 3 factors? Actually, my example 3 has more than 2 factors. So we will demonstrate how that works. But most of them I have 2. But when I get to example 3, I will talk about that. So that is an excellent question. Okay, so example 2, I don't have one side equal to 0 because I have x squared less than 25. So we need to get one side to be 0. So I'm going to subtract 25 basically from both sides. So I'm going to go here on the right, and I have x squared minus 25 is less than 0. So now I need to factor the left side. This is one of the special factors. This is x plus 5, x minus 5. So I have x plus 5 times x minus 5 is less than 0. So those are going to be my two factors, x plus 5, x minus 5. Now I find where each of those is equal to 0. And so I have x plus 5 equals 0, x minus 5 equals 0. That gives me negative 5 and 5. So I'm going to label those on my number line. So now I'm looking at the lines that I'm going to draw, and because it's a less than, it does not include the equal sign, I'm going to draw just vertical lines here. And they're going to be dashed to indicate that these are not included in your answers, which means that any interval is going to be using parentheses. So these are because we have less than symbols. Okay, now I'm going to plug in numbers again. And if it helps, you can write down what number you plug in. So we've got negative 5 here, so we plug in negative 6. Oops, I wrote negative 5. Negative 6. So we can plug in negative 6 because it's to the left of negative 5 on our number line. So negative 6 plus 5, when I plug it in x plus 5, is negative 1. So that's going to be negative. Negative 6 minus 5 is negative 11. That's also negative. And a negative times a negative is a positive. Now I need to pick a number between negative 5 and 5. So whenever possible, I'll pick 0. So if x is 0 and I plug it into each factor, 0 plus 5 is 5, which is positive. 0 minus 5 is negative 5, which is negative. Positive times negative is a negative. And now I need a number larger than 5, so we can use 6. 6 plus 5 is 11, which is positive. 6 minus 5 is 1, which is positive. And a positive times a positive is a positive. So now we're looking for where we are less than 0. So less than 0 means negative. So we're looking for where our multiplication is negative. And that is the middle part here between negative 5 and 5. So that's this section here. And because of the dashed lines, I'm not including my endpoints. I can draw these with parentheses. So if I'm reading this in interval notation, my left endpoint that I've shaded is at negative 5, which has a parenthesis, comma, 5, and then another parenthesis, because that's where the next endpoint is. They both have parentheses because of the less than. And so this is one where your answer is actually between negative 5 and 5. So it could be, if you have two factors, your choices of solutions are generally the two outside ones or the inside. Sometimes you do end up with some weird situations, but most of the time it's either the two outside or the inside. So do you have any questions on this example? For perfect squares like that, can you always assume it will be the positive and negative answer? Yes, for perfect squares, yeah, you're always going to get a positive and negative for your endpoints. Now, whether or not your answer is always going to be in the middle depends on if it's a less than or greater than. Kimmy, that's exactly, how do you know if it's in the inside or the outside? That is the less than or greater than. And so that also depends. So are you looking for something that's less than 0, which is negative, or greater than 0, which is positive? And it depends on what happens when you multiply each factor and you plug in numbers. So it really depends on the chart at the very bottom. And so you can't really make a guess. You have to fill out that chart, because sometimes in the chart, depending on what you have, it'll be a negative, positive, negative. So it's not always going to be positive, negative, positive under the multiplication line. So you really have to figure out the chart, and then you match the chart to whether it's a less than 0 or greater than 0. Let's take a look at another example. So, Caliph, you had your question, what happens if you have more than 2? So here we have x minus 1 squared, which gives us 2 factors, and then x plus 2 cubed, which is 3 factors. So this would give us 5 different factors. And so you would have 5 things written. Now, I actually only have 2 on my chart because they're repeated. So if I wrote this, instead of using them with the exponents, this would be, why is my pen not working? Let's try this again. X minus 1 times x minus 1, and then x plus 2 times x plus 2 times x plus 2 greater than or equal to 0. And so you would have 5 factors. So I have only 2 here because they're the same number, but if they were different, you would have 5 of them listed, and then you would have 5 different zeros that you'd be looking at. So instead of just the 2 points that divide our thing into 3 sections, we would have 6 sections. But here, because they're the same number that shows up, we're only going to have 2 different zeros. So that's why I can still use the simplified version. Otherwise, you have a line for each 0 that you end up with. And sometimes you only end up with 1 0 and you just have 2 sections of a line. So this is already in factored form. And because we have repeated factors, I can do x plus 1 squared and then x plus 2 cubed as my 2 factors. So we can keep the exponents on there because they are the same thing underneath them, basically. And so when you're finding your zeros, because you need to find out where they're equal to 0, you have x minus 1 equal to 0, which gives you x equals 1. And then x plus 2 equals 0, which gives you x equals negative 2. So when you're finding the zeros, you can ignore the exponents, because to get rid of the exponent, you'd be taking square roots and cube roots, and square roots and cube root of 0 is still 0. So our 2 numbers we're looking at are negative 2 and 1. And because it's a greater than or equal to sign, we're going to have solid lines. So I'm going to draw solid lines here because it's a greater than or equal to. So it's that the key is that equal to part means it's solid, which means we'd be using brackets. So I can even just draw brackets there to remind you that you'll have brackets at those places. So now we want to start plugging in numbers. So I want to plug in a number that is smaller than negative 2, such as x equals negative 3. And we do have to pay attention to the exponents here. So if I plug x equals negative 3, and I will just write it to the left, into the factor x minus 1 squared, we'd have negative 3 minus 1 squared, which negative 3 minus 1 is negative 4 squared, and that will give you positive 16. So that gives me a positive. And in fact, every time, everything with an even exponent, everything that's squared will give you a positive. Because if you square a negative, you get a positive. If you square a positive, you get a positive. So that x minus 1 squared is always going to give us positives out. So I can just write plus the whole way through, because I'm always going to get positive out from there, no matter what number I plug in. So now we want to plug in numbers into x plus 2 cubed. So I'm going to stick with the -3 first. So -3 plus 2 cubed. So -3 plus 2 is -1. -1 cubed. We don't care what the number is. If you have an odd power, if it's negative inside, your answer is negative. If it's positive inside, your answer is positive. So I'm going to get a -1 out. So that's a negative, because it's a negative with an odd power, you're going to get a negative. And then multiplying those, positive times a negative is a negative. So this is one example where, if I compare it to the previous one, we had a positive, and the previous two, we had a positive in that first section for the multiplication. And then here's one where I have a negative for the multiplication. So now in the middle section, I want to plug in a number between -2 and 1. So 0 is the best thing to plug in. So if I plug 0 in for x, and I don't have to do it with the x plus 1 quantity squared, because I already know that's positive. So I'm going to plug it into the x plus 2 cubed. That gives me 2 cubed, and that's going to be positive out, because it's a positive inside there. And a positive times a positive is a positive. And now I want to plug in a number larger than 1, because that's the next endpoint. So let's say we plug in 2. And so then 2 plus 2 cubed. So the 2 plus 2, follow order operations, is 4. So that's 4 cubed. And a positive inside means we have a positive outside. That's positives. And again, we have a positive times a positive, which is a positive. So here's a different situation where we were alternating signs in our previous two. So example 2, we had plus, minus, plus underneath for the multiplication. Example 1 also had plus, minus, plus. But for example 3 here, we have minus, plus, plus. So they're not actually changing, they're not alternating. So now I need to determine, well, what am I looking for? So I am looking for greater or equal to 0. So numbers that are greater than 0 are positive. So I am looking for the plus signs, the positive numbers. And so that is the middle section and the right section. So I'm including those two sections here. And because 1 is all included the answer, I can just include the whole thing there. So my answer, I'm sort of running out of room here how I'm going to write this. So the left endpoint when I'm reading this on for my graph is at -2. So because smaller than -2, we got a negative. We're looking for greater than or equal to 0. So I have -2 with a bracket because it's a greater than or equal to. And then I'm including 1, so I can just keep going all the way to infinity. And so in this case, our answers are basically anything greater than or equal to -2. So there are questions on this example. Okay, Caleb says he's all good. Kimmy, if you have questions, let me know. Otherwise, I will move on. I do have another example. You're good. Okay. So you really do have to make the chart. Often what I see on the homework assignment is that people don't make the chart and they just assume that it's going to be like the 2 endpoints or something like that, but you can't do that. You have to make the chart. Okay, now example 4. So this one, we have less than or equal to 0, and we need to factor this one. So we've got x squared minus 6x plus 12. So factors to x minus 4 times x minus, nope, 4 times 3 is 7. Let's see. Trying to do this in my head. They both have to be, well, 6 times 2 is 12. That doesn't get you negative 6. 4 times 3 is 12. That gets you negative 7. 12 and 1, that won't get you. So I'm going to have to use a quadratic formula here because this is something that doesn't factor. So if you get something that doesn't factor and you've gone through all the possibilities, you have to use a quadratic formula to figure out where it's going to be 0. So just rewrite the quadratic formula here. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so a is 1 because the number in front of the x squared is 1, b is negative 6, and c is 12. Okay, so going through this math here, we have x equals negative b, which is negative 6. So I've always had parentheses when I use my negatives, plus or minus square root of b squared, so that's negative 6 squared, minus 4 times 1 times 12 over 2 times 1. I'm going to grab my calculator. So x equals negative 6, so let's cancel. I have 6 plus or minus. And then inside the square root, negative 6 squared is 36. And then 4 times 12, I believe, is also 36. 48. Apparently, I cannot do my multiplication of 12s. 3 times 12 is 36. 4 times 12 is 48. Okay. That's why I have my calculator. And then 2 times 1 is 2. Okay. Now, 36 minus 48, that's going to give me a negative, plus or minus, negative 12 over 2. Okay, now if I have a negative inside my square root, that means I'm going to get imaginary numbers. And if we get imaginary numbers, that means that there are no real numbers where it equals 0. No reals that equal 0. So I don't have any parts on my graph, any separations. It's either all going to be greater than or equal to, or all of it is going to be positive, or all of it is going to be negative. Because there's nothing that's, they're imaginary. There are no real numbers that I can use for cutoff points. So we're only going to have, our only possible answers are going to be all real numbers or no solution. Because we don't have any parts where it's going to be changing from positive to negative. So the easiest way to do this is to just plug in x equals 0 to determine, because it doesn't matter what x you plug in. There's no cutoff here. So if say x is equal to 0, and I plug it into my original function, that's 0 squared minus 6 times 0 plus 12. And then I'm looking to see where that is less than or equal to 0. So 0 squared is 0, minus 6 times 0 is 0. So I get 12 is less than or equal to 0, which is false, which means we have no solution here. So this inequality doesn't have a solution because there is never a point where it's going to be less than or equal to 0. And that was because we had imaginary numbers when we used the quadratic formula, which means that we just have to pick one number to figure out if it's something true or false. X equals 0. So you could pick any number for x. If you get something that ends up being imaginary that doesn't have real numbers for x, if you have complex numbers, you can pick anything to plug in. 0 is the easiest thing to plug in. So whenever possible, pick 0. There are other questions. Before I move on to rational functions, I want to show you what this means graphically, like on an actual 2D graph, what these things mean. Oops. Okay, so for the example we just did, we had x squared minus 6x plus 12. So we're looking for where that is less than or equal to 0, and that's basically the y values. So we're looking at where our graph is below 0, below the horizontal line. If you look at it, it's never below 0. So that's why there's no solution. Our graph never gets a negative y value. So it's never less than or equal to 0. So let's switch to example 3, and let's graph example 3, and we should see that it's below 0 from -2 to infinity. So example 3, we had x minus 1 squared times x plus 2 cubed. And we're looking for where is it greater than or equal to 0. So it's equal to 0 at -2 and at 1, which were the two values that match when we factored it. And it's greater than 0 everywhere to the right of -2, because everywhere on the right side there, our graph is in the positive part of the graph. It's in the upper part. So if it's above the horizontal line, then that's a positive. And we're looking for where is it greater than or equal to 0. And so it's greater than or equal to 0 everywhere, x value of -2, and then moving all the way to the right. So that matches our answer here. So now let's look at example 2. We had x squared less than 25, and we had solved that to be less than 0. So we're really looking at x squared minus 25. So I'm going to bring up the graph. X squared minus 25, and we're looking for where is that less than 0. Well, it is below our horizontal axis between -5 and 5. Which is what we got for our answer. That's where it's less than 0, it's below our x-axis. And then example 1, we had x squared minus 2x minus 8. And we're looking for where is it greater than or equal to 0, where it's above the x-axis. So if I graph that one, x squared minus 2x minus 8. So it's above if we're to the left of -2, and then to the right of 4 on our x values. That's where it's above 0 for a y value. Everywhere between -2 and 4, it's negative, and that's not what we're looking for. We're looking for the greater than part. So we're looking for the part where it's above. So the sign chart that I'm doing is basically telling us whether it's above 0 or below 0 on the y-axis. Is it above our horizontal line, our x, or is it below the x? And where is that occurring? For what x values is that occurring? Does that help you understand basically what we're doing here and what we're finding and what this stuff means? Okay, let's take a look at, I'm going to skip to the rational, because those are the polynomial ones, and then there's also rational ones where you have fractions. So again, I have all of the steps here. This is very similar. It's the same idea. It's a little more to worry about than the polynomials. But you still have to have one side with 0. You still need a factor, but now you're factoring the top and the bottom of your fraction. You set each factor to 0, so the top for 0, the bottom for 0. You create a chart, and then you plug in values, and then you're dividing, whether a positive divided by negative, and doing that thing. But it's the same idea. The main difference is that your factors are not always going to match. So you're looking at the numerator, which could be positive or negative, or which could be solid or dashed. But the denominator numbers are always going to be dashed because we can't include 0 in the denominator because we can't divide by 0. So the numbers you get from the denominator, from the bottom, are always going to be dashed. The numerator comes from whether it's what the symbol looks like. Oops, too many. Okay, so let's look at example 1 here. So we have one side with 0, and these actually are already factored because they're not quadratic. We actually have linear things here, and that's completely okay. So you're going to set the top equal to 0 and the bottom equal to 0. So the numerator is 4x minus 1, so that equals 0. And then you need to set the denominator equals 0, x equals 0. And because x equals 0 is the denominator, that one is going to be dashed. Now the 4x minus 1, so when I solve, I'm going to add 1 to both sides, so I get 4x equals 1. And then you divide both sides by 4, so you get x 1/4. And this one is also going to be dashed because it's a less than symbol. So I'm going to put on my chart 0, and then 1/4 is bigger than 0. And both of these are going to have dashed lines, one of them because it's in the denominator, and one of them because of the less than. And then I'm going to just write denominator, so you know which one goes with which. So the 0 came from the denominator, so that one's dashed. The 1/4 came from the numerator. It gets the symbol, the less than, so that one's dashed. So now we're looking at the same idea. You're plugging in numbers into each factor. So factor 2, really doesn't matter the order that I write these, but let's say x minus 1, and then x. And then we're looking at what happens when you divide. So I want to plug in a number smaller than 0. So let's say we plug in -1, because that's easy to plug in. So I'm plugging -1 in for x for 4x minus 1. So 4 times -1 is -4, minus 1 is -5. So I'm going to get a minus. X, well, if I replace x with -1, that's negative. And then a negative divided by a negative is a positive. Now I need to pick a number between 0 and 1/4. So this is harder because you're definitely going to want a calculator here. These aren't whole numbers. So 1/4 is 0.25. So let's say we just plug in 0.2, because I know that's smaller than 1/4. So I'm going to use my calculator here. 4 times 0.2, and then minus 1 is -0.2. So that's going to be a negative. And then x is 0.2. 0.2 is positive. Negative divided by a positive is negative. And now I want a number bigger than 1/4, and I always prefer whole numbers. So let's say we pick 1. 1 is larger than 1/4. And if I plug 1 in for x, 4 times 1 is 4, and 4 minus 1 is 3, so that's positive. And then x, well, if x is 1, that's positive. A positive divided by positive is a positive. So now I'm looking for where we are less than 0, which means we are negative. So I'm looking for the negative parts for the division. And so that's between is 0 and 1/4. So that means my answer is the section between 0 and 1/4. So when I write this, my left endpoint is at 0. And because of the dashed line, we're not including 0, so that's a parenthesis. And then my right endpoint is at 1/4, because that's where the negative part stops. And that has a dashed line, so that is also parenthesis. And so in this case, where we are less than 0 is between 0 and 1/4. So I'm going to just bring up Desmos to show you what this means for something that we have rational. So I've got 4x minus 1 over x. So we're looking for where we are below the x-axis. And we're below, it hits here at 0.25. So our graph is below between 0 and 0.25. And you can zoom in to see it a little bit better. But that's the only part we're negative, where we're below the x. Everywhere else on this graph, we're above it. So if we're looking for the parts where we're less than 0, it's just this really tiny small segment here. Everywhere else, it's above the x-axis. Are there any questions? Okay. So I do have more examples, of course. Here's example 2. We have x squared minus 1 over x, which is greater than or equal to 0. So again, we're looking at the numerator and the denominator. So that where the top is equal to 0, so that's x squared. Oh, I thought I was on the pen. X squared minus 1 equals 0. And then where the denominator is equal to 0, which is x equals 0. And that one is going to be dashed because it's the denominator. Now, x squared minus 1 equals 0, I can solve this by taking square roots. Or you could factor. If I add 1 to both sides, I get x squared equals 1. And then when you take the square root of both sides, you get x equals plus or minus the square root of 1, which is 1. So we get plus or minus 1. So now we have 3 numbers because we have x equals 1, x equals negative 1, and x equals 0. The 1 and negative 1 are going to have solid lines because of the greater than or equal to symbol, because of the equal to part. That means it's going to be solid. So I'm going to write my numbers here. I've got negative 1, 0, and 1, because I have to make sure I put them in order. So Caleb, this is another example. You would ask what happens if you have more than 2 factors. Here's one where we have 3. So I'm going to have a dashed line 0, because that's from the denominator. And then I'm going to draw solid lines at the other 2 to indicate that those can be included. So those are going to have brackets, while the dashed line is going to be involving parentheses. Now we want to do the factors. So the question, if you solve it and you did not solve by factoring, how do you write your factors? I have x plus x equals 1. Well, if I solve x equals 1 and subtract 1 from both sides, that gives me x minus 1 equals 0. The other one, if I add 1 to both sides, I get x plus 1 equals 0. So your factors are basically going to be x and then the opposite sign of what it is. So if you use the quadratic formula even and you got 1, then your factor would be x minus 1. So it's going to be the opposite of the sign. So I have x minus 1, x plus 1, and then x. And now I'm going to plug in numbers. So I need to plug in a number smaller than negative 1. So let's say we use negative 2. So if I plug negative 2 in for x, negative 2 minus 1 is negative 3. That's negative. Negative 2 plus 1 is negative 1. That's still negative. And then x, negative 2, so that's negative. So when you have 3 of these and you're looking at the division, it actually really doesn't matter because 2 of them are multiplied. It doesn't matter. All you need to know is that if there is an odd number of negative signs, your answer is negative. If there is an even number of negative signs, your answer is positive. So a negative divided by a negative is a positive, divided by another negative is negative. We have 3 negative signs, that's odd, so we're going to have a negative in the end. So now I need to pick a number between -1 and 0. So let's, in this, have to pick a decimal. Let's do -0.5 is probably the easiest one. So -0.5 minus 1 is still going to be negative. -0.5 plus 1 is a positive 0.1, so now that's positive. And then x is negative, so that's negative. 2 negatives make a positive, so we're going to have a positive underneath because it's an even number of negative signs. Now I need to pick a number between 0 and 1, so unfortunately I have to do another decimal, so that's going to be 0.5. It doesn't have to be 0.5, I just find it easy to pick halfway between. So 0.5 minus 1 is -0.5, so that's negative. 0.5 plus 1, that's going to be positive. And then x, 0.5, that's positive. 1 negative sign, that's odd, so our answer will be negative. Now I want to pick a number that's larger than 1. Let's say we pick 2. So 2 minus 1 is 1, so that's positive. 2 plus 1 is 3, that's positive. 2x is positive, so that's positive, and all those positives are going to give us a positive. So now we go back to what we had. We had a greater than or equal to 0, which is positive. So we're looking for the positive parts. So that means we're looking for the part between -1 and 0, and then from 1 to infinity. Those are the 2 parts that have the plus sign. So the first left endpoint is at -1, which is going to be a bracket because that's a solid line, it's included. Then we stop at 0. We stopped highlighting at 0, but that's a parenthesis because it's dashed. And when we have a gap, we have to use a U to combine it. Then the next part we start highlighting is at 1, which is solid. So that's a 1 with a bracket. And then we go to infinity, which always has a parenthesis. And so this solution is -1 to 0, and then 1 to infinity. So I'm going to bring up a graph for this one. I have x squared minus 1 over x. Turn off the other one. So we're looking for where is it greater or equal to 0. So it's greater than or equal to between -1 and 0. And it's not including 0. 0 is called an asymptote. That's something special that you will learn about in week 6. And then we're above again once we go to 1, and then we get larger than 1. That's the next section that we're above. And those are the parts where we're positive. Are there any questions? Yeah, this kind of stuff is much easier to learn via video than from the textbook. Okay, Kimmy, you're going to ask if it mattered that it didn't touch the 0. So, yes. So that's why we have to use the parenthesis. Because 0 is in the denominator, we can't divide by 0. So that's why it doesn't touch 0. And so we have to have that parenthesis. And on the graph, it will actually never hit 0 either. Oh, I see Caliph is still typing. Oh, you're good. Okay. Sometimes it lies when it says you're typing, you're not actually typing. So okay. All right. So I have one more example. This is going a lot longer than I thought it was going to be. I should have split this up almost in 2 sections like I did the quadratics. Next time I will. So this is my last example. And this one doesn't have 0 on one side. So we have to make one side equal to 0. So we need to subtract 1 from both sides. So I'm subtracting 1. Now, this means we're going to have something where we have like a fraction and then this minus 1 be less than 0. In order to do this whole process, you have to have a single fraction. So that means we need to get a common denominator here and build a single fraction. So this is going back to P.5, where we had to add and subtract rational functions or rational expressions. So my denominator is x squared plus 4. So I need to multiply. Basically, I have -1, which can be turned into a fraction by putting it over 1. And I need to multiply the top and the bottom by x squared plus 4 in order to get the common denominator. So I have 3x squared over x squared plus 4, then minus x squared plus 4 over x squared plus 4, then less than 0. Now when I combine these, that negative, that subtraction, is subtracting both the x squared and the 4 because it's subtracting that whole thing. So I get 3x squared minus x squared minus 4 over x squared plus 4 is less than 0. Then 3x squared minus x squared is 2x squared minus 4 over x squared plus 4 is less than 0. Now I need a factor at the top. So on the top I have 2x squared minus 4, and I can actually just set that equal to 0 to start doing the factoring process. I'm going to just do that in a different color here. So I've got 2x squared minus 4. You know, I can actually solve this by square roots because I don't have that middle term. So we can add 4 to both sides. So I have 2x squared equals 4. And I divide both sides by 2, which gives me x squared equals 2. And then I take the square root. So I have x squared equals plus or minus the square root of 2. Or not x squared, sorry, x. X is plus or minus the square root of 2. Now, when we now we're going to use the exact. Now, the denominator, we have x squared plus 4. So we have to set that equal to 0. And that one we can also solve by taking square roots. So if I subtracted 4 from both sides, I have x squared equals -4. And then you take the square root of both sides. X equals plus or minus, and you're going to get the square root of -4, which is going to give us a complex number again. And so if it's complex, we don't have to worry about that. So that means we don't have to worry about the denominator being 0 because it's never going to equal 0. So the only numbers I have are plus or minus the square root of 2. So negative square root of 2 and positive square root of 2. And I'm looking for where these are less than 0, so that's going to have dashed lines. And now you're going to want to use your calculator because to figure out what the square root of 2 is equal to. It's like 1.4. So negative square root of 2 is negative 1.4. So if I need to plug in a number less than that, I can plug in 2, or negative 2. And like I said with my factors here, where it's plus or minus. So for we x plus the square root of 2 and x minus the square root of 2. So it's just the opposite sign of what your zeros are. And then you're going to want to rely on your calculator. So negative 2 plus the square root of 2 is negative point something, so that's negative. I don't care what the number is, I just care if it's a positive or negative. And a negative 2 minus the square root of 2 is also going to be negative. Negative times negative is a positive. Now I want to plug in a number between negative square root of 2 and square root of 2. 0 is in between there because they switch signs. So 0 plus the square root of 2, that's positive. 0 minus the square root of 2, that is negative. Positive times a negative is a negative. And now I want to plug in a number larger than the square root of 2. So since square root of 2 is 1.4 something, plug in 2, that's bigger. 2 plus the square root of 2, that's positive. 2 minus the square root of 2, that comes out to a 0.58 something, so that's still positive. A positive divided by a positive is still positive. So the numbers are a little messy. You have to deal with some messy things, but the process is the same. And we are looking for where we are less than 0, which is negative. So that is the negative part here. That is between negative square root of 2 and square root of 2. So when I write this in interval notation, they were dashed because of the less than. We didn't have to worry about the denominator. So it's negative square root of 2, comma, square root of 2. And that's our answer. My comma isn't very much in between them. Oh, too much got erased. Here we go. My computer is being a little slow right now. So do you guys have any questions? So it does not include the square root of 2. Yeah, if you plugged in the square root of 2, you will get something that is false, that is not included, if you plugged it into your original. So you would get something that instead of like being less than 0, or in the original, which is less than 1, you would get something that's greater than 1. Oh no! Can you hear me now? Okay, let me... Okay, Kimmy can hear me. Oh, okay. So Caleb, I will type for you. If you plug in the square root of 2 into the original, you will get something larger than 1. Okay, and let's see, Kimmy, your question was in the assignment, do you have to graph out all 4 parts of the last problem or just the bottom 2 with the lines? Okay, so on the assignment, the polynomial is a quadratic, so there should be only 2 factors. So, where's my mouse? You're going to want to do a graph. similar to like one of these. And that's why on the template I set it up that way, because you're going to have two. And this is the same thing with the rational function one. The rational function will only have two of them, so you can set it up that way. So the line on the template are exactly the same setup that you would need to do on the assignment. And so you want to make sure you fill that in because that's what you need in order to determine your solutions. Any other questions? That last one with the square root was my last example because that one's a doozy. But hopefully you've seen enough of them that you have an idea, and I try to give you different examples of how the different possible combinations you can see of these things. So anything else? And the ones on the assignment are factorable, so they won't be as complicated as some of the ones that I did here, because they should factor nicely. Yeah, that's right. Luke came here. He says that's right. Forgot about that. Okay. Perfect. And Kimmy, I'm going to assume since you're not typing, you don't have any more questions. So, all right. So I'm going to stop the recording, and this is probably, I'm going to try to put it up tonight because I know that this stuff is due tonight. But I do have a one-on-one that I'm actually running late on. So, whoops, that poor student. Hopefully they're waiting for me. So I'm going to pop up here, stop the recording, do all that so I can get to my one-on-one. But I will try to put this up as soon as possible, and I'll send out an email so you guys have it. So, all right. Pop off. So find my mouse.